Okay, so the next thing we're going to talk about is finding coterminal angles. So let's just make this observation. Let's look at this angle here. Here's an initial side and here's a terminal side. What angle could describe this situation? What's the measure of this angle between these two, the initial and terminal sides? Well, we could say it's 140 degrees, right? Or we could say it's minus 220 degrees. There's two different ways, completely valid, that we could describe this angle. Can you think of another way we could describe it? What if we said 500 degrees, right? If we went all the way around once and then back 140 degrees, 140 more degrees, so 360 plus 140 would be 500 degrees. That's another way. So those are what we call coterminal angles. Okay, ways we can describe an angle where the terminal side is at the same spot. Okay, we end up at the same spot. Those are coterminal angles. Okay, so let's talk about those for a minute. And let's also talk about reference angles. We've also talked about these just a little bit. So coterminal angles are two angles in standard position that have the same terminal side, just like we talked about in the last slide. Okay. All right, an angle's reference angle is the size of the smallest acute angle T prime formed by the terminal side of the angle T and the horizontal axis. Okay. Reference angles are something we're going to use this whole semester as well. This is the first time we're talking about them. So here, the reference angle for this angle would just be T, just be itself. Okay. But let's look at this red angle, this terminal side, if the terminal side was this red angle here. Okay, what's the smallest acute angle formed by the terminal side and the horizontal axis? It's this right here, T prime. Okay. So the reference angle for this red angle would be T prime. How about here? If the terminal side is down here in quadrant 3, here is our T prime. And how about if the red side, the terminal side, is all the way over here in quadrant 4, the smallest acute angle between that line and the x-axis is T prime here. Okay, so all of these T primes are the same, and they all are the same as this angle T. Okay, so these aren't coterminal. Okay, we're just talking about reference angles for different places that the terminal side could be. Okay, the reference angle is the smallest. It's the angle between that terminal side and the x-axis. Okay, so it could look like this, could look like this, or it could look like this. Okay, we'll talk a lot more about reference angles as we go through different topics this semester. All right, so let's go back to coterminal angles. It says find the least positive angle theta that's coterminal with an angle measuring 800 degrees. Okay, so it looks like if here's our terminal side, this has gone around and around and around, partly gone around twice and then a little bit more. Okay, and this is kind of giving the answer away. Okay, but how would we find that? Okay, if they tell us it's 800 degrees, so you can see usually we're interested in the measure of an angle that's between 0 and 360 degrees. Okay, we're looking for a positive angle that's between 0 and 360 or 0 and 2 pi, depending on whether we're doing angles or degrees. Okay, so let's just look at how we'd solve this. There's not a lot of magic to it, right? If we have an angle that's 800 degrees and we want it to be between 0 and 360, let's just subtract 360 from it. And we get, let's see, minus 300 is 500, so that would be 440 degrees. Still not between 0 and 360. So let's do it again. And we get 80. Voila. That's it. So if you have a big angle, just subtract 360 from it until you get something between 0 and 360. Not too surprising. All right, what about this? Show the angle with measure minus 45 degrees on a circle. There we go. That part was done for us. Here's minus 45 degrees. And find a positive coterminal angle alpha such that it's between 0 and 360. So we're looking for this angle, which again, they give us the answer. Okay, but how could we find that? We would just say, we'd say minus 45 degrees. We could just add 300. Ooh, that got messy. Plus 360 degrees, which is going to be 315 degrees. And, we could just keep adding 360 until we got between 0 and 360 if necessary. So again, not too, nothing fancy. What about if it's in radians? Find an angle beta that is coterminal with 19 pi fourths. Okay, where beta is between 0 and 2 pi. So again, here we are in radians, so we're going between 0 and 2 pi, and degrees, you go between 0 and 360. All right, so how would we do this? Again, they're telling us the answer. So 19 pi fourths, it's gone around and around and ends up over here. You don't really, I don't have any necessarily intuition about where that is. If you don't, that's fine. It's just some big thing, and we want to put it smaller so that we do have some intuition. We're going to end up with 3 pi fourths. But pretend we didn't know that already. How could we find it? All right, so let's look. Okay. Find the angle beta that's coterminal with 19 pi fourths. All right, so 19 pi fourths. What's the equivalent of subtracting 360 degrees? It is subtracting 2 pi, right? 2 pi. How could we write 2 pi with 4 as a denominator so that we can actually subtract it? Right, so 19 pi fourths minus 2 pi. I mean, these are fractions, right? Got to find a common denominator. 19 pi fourths with 4 as a denominator, 2 pi I could write as 8 pi, right? Which is going to give me 11 pi fourths. So again, I could subtract 8 pi fourths, which is going to give me 3 pi fourths. So, I mean, in radians, the only thing that's a little bit trickier is sometimes you have to find a common denominator to be able to subtract the two fractions. But you guys are good with fractions, you can do it. All right, I think that's all I wanted to do in this section. Yeah. All right, so that's coterminal angles.